In this video, we're going to start looking at the mechanism for nucleophilic substitution reactions. And we're going to have two different types of mechanisms, and we're going to differentiate between the two based on kinetics. So two types of nucleophilic substitution. I'm going to write reactions, but specifically it's the mechanism, how we're going to substitute. So two different ways we can substitute, right, using a nucleophile. And as I said, it's going to be based on kinetics. So our first one, our bond making and breaking is going to occur at the same time. So this is going to be concerted, right? As we break our sigma bond between the carbon and that halogen, we're going to make our new sigma bond between the nucleophile and that carbon. So our bond making and breaking occurs at the same time. We would say it's concerted. It's going to be a one-step mechanism. So we're not going to go through an intermediate, right? I'm not going to break a bond, have an intermediate, and then form a bond. It's going to occur at the same time. So it's going to be a one-step mechanism. Both the alkyl halide and the nucleophile are involved in the same step. And that step is going to be my rate determining step. If you remember from 152, right, our rate determining step is the slowest step of our reaction. Right, remember, a reaction can never proceed faster than its slowest step. So its slowest step is going to be the one that determines the rate. Rate determining step, I usually abbreviate it RDS. And then just a reminder, rate determining step, this is the slowest step of the reaction. Right? Our reaction can never proceed faster than our slowest step. So the overall rate of our reaction, right, how quickly we can go from reactants to products is determined by this step. And that's why we give it the name rate determining step, right? It determines how quickly reactants are converted to products. Right, we can look at it as the amount of reactants decreasing or the amount of products increasing. Since these reactions only occur in one step, that one step has to be rate determining, right? There isn't any other option. So it determines how quickly reactants can be converted to products. So since both the alkyl halide and the nucleophile are involved in this one step, and it's only one step, both the alkyl halide and the nucleophile are involved in that rate determining step. We would call this a second order reaction, right? It involves the concentration of two things, right? The concentration of my alkyl halide and the concentration of my nucleophile. So this is a second order reaction. Again, remembering back from 152, right? Something that second order has the concentration of two things, or the concentration of one thing raised to the second power. In this case, it's going to be two things that determine the rate. We could say this is a bimolecular reaction. So if I was to write the rate law for this, if we remember again back to 152, our rate laws are always in the form of rate, an equal sign, and then a lowercase k It's important that it's lowercase, right? A capital K is going to be an equilibrium constant. Rate constants are lowercase k's. And in this case, the concentration of my alkyl halide, brackets mean molar concentration, and then multiplied by the concentration of my nucleophile. Because I have two things, right, my alkyl halide and my nucleophile involved in that rate determining step, it is second order or bimolecular. If I was to look at the mechanism, right, I have my nucleophile. I'm just going to use an R group for now, but what's happening is that nucleophile is attacking the partial positive carbon that that halogen is bonded to at the same time that that leaving group leaves. I'm not going through an intermediate. I now have my nucleophile bonded to that R group, and then my halogen is by itself. So bond making and breaking are occurring at the same time. That means it's concerted. That's what that word would mean. It's second order because that step involves both the nucleophile and my alkyl halide. Our second type of mechanism, we are going to break our bond, and then we're going to form the bond in a subsequent step. So bond making and breaking does not occur at the same time. And we're going to break the bond before we make our new one. So the bond between carbon and the halogen is going to break. We're going to have an intermediate, and then we're going to form a bond between the nucleophile and that intermediate. So bond breaking occurs first. Then bond making. So this is going to be a two-step mechanism, right? We're going to break the bond and then form the new bond in separate steps. So a two-step mechanism. It does go through an intermediate. And specifically, it's going to be a carbocation intermediate. And the rate determining step only involves the alkyl halide. So my first step is actually going to be rate determining. So the rate determining step only involves the alkyl halide. Since only one of my species is involved in the rate determining step, it's a first order reaction. We could say it's unimolecular, right? Only the concentration of one thing is involved in that rate determining step, so first order. If I was to write the rate law, always the word rate, an equal sign, always a rate constant, and then the part that varies is what comes next. In this case, it's just the concentration of the alkyl halide. So just kind of going back and looking at the two, because we probably haven't seen these in a while, right? Second order, I have two things involved in a rate determining step, bi for two. First order, I only have one thing involved in my rate determining step, unimolecular. Be really careful not to get the order of the reaction and the number of steps in the mechanism confused, right? If I go back up and look at my bimolecular reaction, since both the alkyl halide and nucleophile are involved in the same step, it's a one-step mechanism. So the second order reaction occurs in one step. So the bi doesn't mean it has two steps, right? Bimolecular second order means I have two species that determine the rate, right? The concentration of both the alkyl halide and the nucleophile affect the rate because they're in the same step, which happens to be the only step. When I look at this one, it's first order. Only the concentration of the alkyl halide affects the rate. The concentration of the nucleophile does not affect the rate of this reaction. I can increase it, I can decrease it. It's not going to speed up or slow down my reaction because it's not part of the rate determining step. Because the nucleophile is involved in a separate step than the alkyl halide, This first order reaction takes place in 2 steps. So be really careful. It's a really common confusion, particularly once I give you the names of these, is that the order does not tell us the number of mechanistic steps, right? The order tells us how the rate varies with concentration. So varying the concentration of the alkyl halide is going to increase my rate for this one. Varying the concentration of the nucleophile has no effect. If I go back up and look at my second order one, varying the concentration of the alkyl halide affects the rate. Varying the concentration of the nucleophile also affects the rate because they're both involved in that rate law, right? We could go down and write that note. Changing the concentration of the nucleophile does not affect the rate. You could increase it by a factor of 10 and it's not going to change how quickly we go from reactants to products. Right? It's not involved in my rate determining step. Looking at the mechanism for this, I'm just going to use Rx again. In my first step, my leaving group is going to leave. I'm going to end up with an intermediate, and then that nucleophile is going to attack in a second step, and then we end up with that substituted product. And then looking at my rate law is the one that has the alkyl halide in it, right? So this is my rate determining step, right? Going from my alkyl halide to that intermediate. We are going to give these names. So going back up to my first one here, this one that we said that was bimolecular, right? It's second order. Both the alkyl halide and the nucleophile are involved in my rate determining step. The mechanism takes place at just in one reaction step, right? It's concerted. This is going to be called an SN2 reaction, which actually stands for substitution nucleophilic bimolecular. For now, I'm just going to write down SN2 and we'll come back and spell that out later. So the 2 stands for bimolecular. Again, be really careful. There's a 2 here because it's second order. Mechanistically, it's 1 step. It's really easy to get these 2 mixed up. So just remember what that 2 stands for. It stands for bimolecular. And again, I will write that down likely in the next video. My second order reactions, this is substitution nucleophilic unimolecular, and our shorter way of saying it is SN1. So this would be an SN1 mechanism. Again, the 1 stands for the fact that it's a first order reaction. The mechanism, if we look at it, takes place in 2 steps, but it is first order, right? It's only the alkyl halide affects the rate.